Okay, hi, welcome to part 2. This since Bandicam can only record up to 10 minutes of video, so this is part 2 of the presentation for the demo of the system. Okay, just now we have already added 2 to 3. Right now you can see that there's a cyclic property for this graph because we have already added 2 to 3 just now. And let's say if you want to test for the cyclic property, you click 7. It should theoretically give us, okay, so it's correct. Now right now it's showing us that the graph has cycle. So it is true because this the cyclic functionality is being done by Shakila, and it is correct because right now you can see that let's say if you start at Bordeaux and go to Moscow, go back to Bordeaux, it has returned back to the starting vertex, and you can see that this shows that a cyclic property is present within the graph. So for strongly connected, let's say if you test for the current graph, see whether it's still it is strongly connected or not. Just now it's not, so you click 6 and you can see that it's still not strongly connected because there are still certain vertices that cannot go to other vertices. For instance, 2 cannot go to 2 can go to 4, 2 cannot go to 1. Okay, so there's no 2 can go to 1, 2 cannot go to 0. Okay, my bad. 2 still cannot go to 0, 2 can go to 3, 2 can go to 4, 2 can go to 1, but it cannot go to 0. Okay, so that's why the graph is still not strongly connected. So that's for the strongly connected and cyclic functionality. And another functionality that I have not yet shown is the reset graph to default. So if you click 4, you can, okay, right now let's just print the current graph. So you click 3 to print the current graph. You can see that all the newly added random edges that I've added since just now, how many? 1, 2, 3, 3. I've added 3 new random edges. You can see that it is now currently on the matrix of the adjacency matrix for the graph is being added. So let's say here 2 to 3. So 2 0 1 2 2 3 2 0 2 1 2 2 2 3 2 3 2 9 2 4. Okay, this is the value. You can see here that just now when we newly added the edge between 2 to 3, you can see that the value has been updated here, and even here 0 to 3 just now, so we update 0 to 3 0 1 0 2 0 3. Okay, this 6687, you can see that the value 6687 is represented in the graph. That means any changes that we made through the adding random edge will be updated in the adjacency matrix. Okay, and another function that I have not yet shown is the remove particular edge. So let's say if you want to remove a particular edge, okay, just now we already add 2 to 3 to check for the cyclic property, right? Actually don't, we add the edge randomly. So let's say if you wish to remove this edge, so you click 5 to remove particular edge, click 5 and enter, and you have to enter the I is 2 3, so you want to remove this edge, let's say, so you click 2 for the I and 3 for the J. So right now the 2 3 has been removed successfully. That means this one so has been removed from the graph. So let's just try to print the graph, and we can see that 2 3 0 1 2 2 0 2 1 2 2 2 3 2 3 is now a the maximum representation for integer value. That means there's no connecting edge between the two vertices 2 to 3. So if you check for the cyclic property again, you click 7, you can see that the graph has no cycle because the edge that helps for the cyclic property has now been removed. So right now it has no longer cyclic properties for the graph. So let's just, okay, so that's for the removing particular edge. Okay, so we can also reset the graph to default value. So if you click 4, okay, you just see for the last time, put in the current graph. Okay, right now this is the current graph. You can see that there are values, the newly added 4 to 1, you can see 0 1 2 3 4 4 to 1. Okay, this is 4 to 1. You see there's a value here, the newly added one. So if we were to reset, we click the 4 function. If we were to reset the graph to default, it will promise this output that it has been reset to default, and we try to print the graph again, and you can see that 4 1 just now, the 13153 4 1 is no longer the value of 13153. Instead it has been represented with the maximum value, which means that there's no available edge that's connecting between the two vertices 4 and 1. So with that, so actually you can add the random edges for 15 times from default, of course. So right now I've already set for to default. So if I add random edges to the graph, I can add 15 times. So let's just for the sake of this one, you can see that we can only add 15 times one, because as I've explained earlier, there's 25 possible cells for the matrix. 5 default value will get you 20, and you minus another the 0 0 1 1 2 2 3 3 and 4 4. There's another 5 values, so 25 minus 5 minus 5, you'll get 15 values. So you can only add newly random edge 15 times before the graph will be full in terms of adding new value to the matrix. Okay, so with that, I think I end the presentation. Thank you for listening. So if you want to exit the application, you just click -99 and click enter, and it will prompt a thank you and have a nice day. Thank you.